we got to do the dance-off competition. Maya, Hustle, where are you, dude? Oh, we'll have to harass them later. All right. Hello, welcome. My name's Monte, and I do coke and strippers. Well, I do coke and strippers for educational purposes only. I mean, I do the YouTube channel, Diet Coke and Wire Strippers. It's an electronics channel. It's Coke and Strippers for short. So anyway, you should check it out. It's awesome. Y'all having fun yet? Hello? Anybody home? Yeah, okay. Oh, and afterwards, I have a few of these little chips to give away. So if you want one, take a picture, tag me on social media, show me afterwards, and I'll give them away till I run out. I'll put this back up later. Okay, so let's get started. So this all comes from the Bloomberg article. Who remembers the Bloomberg article? Yeah. So maybe that there are chips put on the motherboard. We're calling this chipping to attack computer systems. But nobody actually found any evidence that these were in place yet. Everybody denied it. It would be a serious event, though, if it happened, right? Because it's impossible to detect with our normal kind of tools, right? You can check the firmware, you can check the config, you can do all these things, and you won't see the hardware that's hiding inside. So that's kind of different, kind of exceptional about it. Could be in various pieces of equipment. It'll survive re-imaging. Normally, our protocol is if something gets compromised, what do? We take it and put a new flash image on it, or we flash new firmware, or we redo the config. But in this case, it doesn't help, right? That doesn't change the hardware that's built in. And introduced in the supply chain, and that's scary, right? That's something that we don't control, is our suppliers, the people who give us stuff. So if that were a real attack, it would be rather scary. But no definitive proof yet, right? Maybe it exists, maybe it doesn't. So I decided it doesn't matter. Let's make it true, right? Nothing better than taking a good idea and making it happen. And maybe we can make it look better than this. I don't know. So I had to pick a target. And I do industrial control system work. So that was sort of my first thought. And along those lines, I was thinking serial ports, maybe easy, and common in industrial control system equipment, right? Lots of serial ports everywhere. And then once I got there, I thought, well, why not a Cisco firewall? Because not only does that hit the ICS, the industrial control system side, but that sort of hits everybody, so probably a broader interest. So I picked a Cisco firewall because they are popular. You know, it's not that they're particularly vulnerable to this attack. They just drew the short straw. So, so the decision was made to go the serial port. It's fairly easy, fairly simple protocol in lots of industrial control system equipment anyway. Now, as a quick review, serial ports are fairly simple devices, and I want this to be simple, easy. All right, I'm trying to do. You've heard the 80-20 rule. Who's heard like 80-20? All right, you get 80% of the benefit for 20% of the effort. I'm more like the 51 rule. I'm trying to get 50% of the benefit for 1% of the nation state cost. So serial ports, fairly easy. We'll have a transmit line, a receive line, and ground for the serial port. So that's pretty straightforward. Now in this attack, I'm also using a piece of cheap Chinese hardware, these 8-channel serial analyzers. It just helps when I can read multiple serial streams simultaneously, so I'll use this. It seems to me there's some kind of irony, though, in using cheap Chinese knockoff equipment to build a Chinese attack into hardware, perhaps. So, It uses this open source software called PulseView. It's free. I'm not part of not part of that group, but I think it's good software. And if you want to get into kind of hardware hacking, buying one of those $7 8-channel analyzers and using the software is probably a good place to start. But it allows me to look at these serial signals on multiple channels. And here we can see the actual I/O. We see the levels, high, low. These are the actual bits provided. And then finally, if we were going to interpret them as ASCII, these are the ASCII characters, config something with start and stop bits. So as I'm trying to build something that will send and receive serial, this is helpful for diagnostics. So RS-232, or now TIA-232, has these sort of signal levels. It's typically like plus and minus 15 volts, which is what these Cisco devices do. It's kind of plus and minus 15. And that's an issue because I'm thinking about chipping this, building a chip to put in to attack the system, a microcontroller. And these devices are 5 volts typically, or at least, the ones I like to deal with. So plus and minus 15 volts on this communication channel may be enough to fry the microcontroller. Well, that's not good. Perhaps I could add a second chip, a line driver, but then it's 2 chips, and that's, we're trying to keep this thing as quiet, as small, as under the radar as possible. So adding a second driver chip is really not what I'm looking for. But there's a trick. Turns out doing some other work I've discovered from an app note that these devices all have these protection diodes built in. So if the voltage goes too high, it clamps to the VCC side, or if it goes too low, it clamps to the ground rail. And that can keep the device from being harmed, but these protection diodes are only good for like 1 milliamp, not very much current. That's okay, I just have to pick an appropriate resistor, which is about 15 kilo ohms. So with that, I should be able to connect to this 15 volt RS-232 and read the signals. I don't know if I can write them yet, but at least I should be able to read them without frying the microcontroller. And that's a good start. Turns out I end up going with 5.1K, which is a little out of spec for the amount of current that those diodes are supposed to be able to handle, but it works. And I needed a little more current to drive the receiver in this firewall to be able to receive the commands as part of this. Part of this attack. So I'm always trying to start with the simplest thing possible, right? I'm a firm believer that success lies on the far side of failure. Right? So my job is always to fail fast. See how fast I can get to success. So that involves testing things as quickly and cheaply as possible. So I begin with these Arduino boards. I had a Arduino Mega laying around. I'm thinking that's probably the kind of processor I'll use in the end. So it's a quick and easy test. So I wire it up to a serial cable, and it works. I'm able to communicate back and forth. So that's a good start. But now I want something smaller than this, something we can potentially hide, right? This is about chipping, nation-state attacks. It's supposed to be something smaller. So a couple of options I discovered. This AT-Tiny 10, this thing is minuscule, right? Pretty small. And then this AT-Tiny 85. I end up choosing the AT-Tiny 85. I could run this attack with the AT-Tiny 10, but the 85 has some advantages. It has EEPROM so that I can store things in the microcontroller. This 10 does not have storage, so I can't count the number of reboots or try to track how long the system has been up or store anything in it. So EEPROM is good. And it was a lot easier for the development. But we'll see for a couple of reasons, but because I could get it on an existing board that was easy to program, and I could use the Arduino IDE, which is fairly simple, straightforward. So I don't need any kind of special hardware programmer or any complicated development tools. So ATtiny 85. And here's the board that it's on. They're not very expensive. You can get 5 of them for $10 US on eBay or Amazon, either. And a matter of fact, so these are the ones, I have a few of these to hand out afterwards. They're not programmed, that's up to you, but I do have a few of them here with me. But they're relatively cheap, relatively easy to deal with. So decided to use them instead. And if you could tell on the edge of this board, there's this USB connector. So I can plug it straight into a USB cable for programming. And then when I get done, I will unplug it and desolder the ATtiny 85. That's this little chip on this side. This is just the power regulator and some other stuff. So the only part that I really want in the end is this little chip over here. This board just makes it easier to deal with in the setup. So I'm good there. Now to test, right? I'm also paranoid. So I want to test to make sure the ATtiny 85 on this board will work. And I connect it up without trying to solder it to anything to make sure it's going to work. And sure enough, it looks like it's going to work just fine. Here's a little snippet of what the code looks like. The code really isn't very complex. The only thing the code does is it sends various legitimate Cisco commands to the serial port. So it prints out those commands on the serial port. The most complicated part of that was programming this DigiSpark board. Wait a minute. Because normally you just hit the program button in this IDE, and when you do that, like over here, it will take the program code that you have and write it onto the board. But these DigiSparks are a little more complicated. When you're ready to program those, you have to unplug it and plug it back up. So it'll only program for a few seconds after plugging this back up. So if you get one of these and you're trying to program it, you'll need to unplug it and plug it back up for it to be programmed. So after it's programmed, I've tested it. It looks like it's going to work. Now I need to install it on the motherboard on this Cisco firewall. So I have a hot air rework station. It's about $150. It blows hot air out of here. Just makes it easier to pull the chip off of this board. Right? I'm taking this chip off, and since I can heat all the pins simultaneously, it's a little easier to pull it off. You could do it with other tools, perhaps just a soldering iron or some solder wick or solder sucker. There are various different tools to do this desoldering, but the hot air rework makes it a little easier. Once again, I list these devices. Look, I don't get any feedback. I don't get any payback from these companies, but people always ask me, what did you use? How expensive was it? So that's what these links are about. These are just the tools that I used. This cheap Chinese microscope so that I can kind of see the pins and see what's going on. That helped. Tweezers. Oh, I did leave out one thing. I used a cheap soldering iron. I have a nicer one, but the tip on it was too large, and I didn't have any smaller tips. So I have a cheap soldering iron with a small tip, and that's really all the tools that are necessary. So for the installation, this chip needs power, ground, and then for the serial port, we need TX, transmit, and RX, receive. So it would be a 4-wire installation. I could put this chip, anywhere on the motherboard with super glue and run 4 wires and make this thing work. And then I realized that, well, I don't actually need 4 wires because I'm not receiving anything from the firewall back to my chip. I'm just sending commands, so I only need transmit. So now I'm down to 3 wires. So now I can put this thing anywhere on the board that I want. And I just have to run 3 wires and connect them to power and ground and receive on the Cisco side. Wires like that sometimes show up on motherboards. We call them bodge wires when things need to be fixed. So this is one that might show up for real. But what I really don't want to happen is to look like this, all right? This is somebody modifying a circuit. That looks like a mess. It's easy to spot. Nobody wants that. So the next question becomes, is there a better way to install this? A more subtle way to install it? So I'm looking around on the board. Here's one from another device. And I'm looking around on this board. Where can I find power and ground and the transmit, maybe have them relatively close together so that I can connect this chip? And what I discovered, there's this connector on here. This that looks like an Ethernet port, that's the serial connector, RJ45, and 2 USB connectors on there. So serial, USB, USB. On the bottom of that looks like this. So over here, all these are the serial pins. And then here are 2 rows of USB pins. So now relatively close together, I have power, I have ground, and I have the receive line that I need to connect to. So that's getting better. Take a little detour here. So this is a small resistor, very tiny. Anybody knows what is the value of this resistor? Come on. What's the value? 0, right? This is a 0 ohm resistor. Why do I want a 0 ohm resistor? Well, yeah, sometimes you use it for a placeholder or a jumper of some kind. And in this case, I use it as a jumper. Its value to me is that this chip will fit right between those pins, more or less, on the bottom of this motherboard with a 0 ohm resistor. I use the ground from the serial port because the power and ground on this chip are kind of diagonally opposite, right? I've got power down here from the USB supply. I've got ground over here from the serial port. And then I have the RX, the receive port on the firewall there together. And the resistor that I need for the receive port and combined with the 0 ohm resistor makes it pretty much just fit in place, right? It's not beautiful, but it's not bad. I'm impressed. I'm like, I've got this thing, right? That's easy. Look, I found a place. It fits. It's perfect. So I fire it up. And part of the trick of this, we'll talk a little more about it later, but part of the trick is that you have to catch these firewalls during the first few seconds of the boot and send them some escape characters. But after I installed this chip here, it didn't work anymore. It turns out that they don't enable the power to the USB ports until after this firewall has entirely booted. It's like, now what am I going to do, right? It's the middle of the night. I'm getting ready to come to a conference. I did all the testing. It works out, but no power. So, well, I guess worst case, again, I can run a bodge wire. I mean, I was so happy this was going to work, but I don't have power. Start looking around for where power might be nearby, other places, looking around where it comes from. And I find this chip nearby. This is the power distribution switch. Its job, and what it actually does, is it takes a small signal from the computer on the firewall motherboard, and when it gets that signal, it turns on the heavy-duty current to power those 2 USB ports. Oh, now we're getting somewhere. We see, I see where the signal comes in and where the power goes out. And so what I realize is that if I bridge 2 of the pins on this power switch, it will stay on all the time. Right? And the easy way to do that is with a solder bridge. So sometimes a mistake on a motherboard is when 2 pins are accidentally connected together. In this case, I did that on purpose. Like, I think this is the coolest part, the coolest hack of the whole thing, right? Is that I get to use a solder bridge as part of the attack. And if you look at it, who here does electronic work as a hobby or profession? Okay, maybe a third of the audience, maybe a little less, right? So a solder bridge is normally a bad thing, but you might, it might pass as an accident. In any case, now I can get power when the machine first comes up. So I am happy. So now you've seen where this chip goes. You've seen it installed. Can you find it, right? It's somewhere. This is the front of the motherboard. This is the back. It looks like these are a little fuzzy here. Those are kind of hard to see. I'll hold this up. Is this better? Okay. All right. Well, it's on there. It's actually right there. You could see it. I mean, we posted this picture once without the circle, and I'm like, maybe somebody will see it, possibly. I kind of doubt it. Actually, 2 people saw it fairly right away. One of them was a buddy of mine who does a bunch of reverse engineering. I'm like, come on, geez. Like, yeah, the ground fill shouldn't have any chips there, and it's obvious that that's, and besides, it's a crappy soldering job. I'm like, yeah, okay, thank you. Appreciate that. So it's not impossible, right? You can find it if you look, but in order to actually find this thing, I counted, you have to take 14 screws. This is it in the case. You take 14 screws out, including a couple on the motherboard, and you pull the motherboard out and turn it upside down. And then if you look over here in the corner, there it is. So let me ask you this. You get a brand new piece of security equipment for your site. What's the first thing you do? Take all the screws out of it and pull the motherboard out and turn it upside down? Anybody? Oh, okay, we got at least one. Paranoid. I'm with you. There are better hiding places, actually. So in this connector, in this can, you can desolder 4 pins on the bottom and pull this metal shield off. And in the back of this, so this is the front side, this is the back side. In the back, there's more space than in the front. You could hide the chip in there, solder this can back on. Now, if you're going to look for it, you have to take it apart and you have to desolder all these different cans and metal pieces and pull them off of your brand new equipment and put it back together before. So, not particularly likely. This is my secret weapon right here, right? I found these on eBay. They're awesome. They're a warranty void if removed stickers. They have a hologram. They're serialized. They have a barcode. They look super official, right? You shove one of these on the box, nobody's going to open it. No. It's like supply chain judo, right? You're using the defense against supply chain attacks to implement a supply chain attack. What's better than that? Love those. All right, so it is time for a demo. We're going to start with a serial cable. Let me change up the screens here for just a second. All right. Well, I was doing that anyway. So let's imagine that a security administrator somewhere just bought them a new firewall and they've set it up, and I'm just now booting it. Turn the switch on. You'll see it boot through a regular serial connection. So the last thing they do before they take it off their desk, right, and put it into the rack is they're going to do one more boot, one more look at that, and that's what this is. Notice it's waiting a few seconds for this escape, but Nobody presses any keys, right? We're just going to let it boot and test it. So in this window, let's see. All right, I'm just pinging this device to see when it finishes rebooting and comes online, waiting for it to boot. Like you would. So you imagine system administrator gets this, he sets it on this desk, he or she connects up a serial port, they configure it, they put in the passwords and the routes and so forth, because when they get done, they're going to take this, and if it's a larger device in particular, then when they get done, they're going to put it in a rack somewhere in a server room. So, our last check here, waiting for it to come up. There we go. Now we have pings. So this device is up on the network. I've got an Ethernet cable here that I can check it with too. And after that, I'm going to run an Nmap scan. Who here anybody use Nmap? Okay, yeah, at least half the audience. That's to see what services and ports are available on this device. And if we take a look here, basically I just checked a few for the demo. None of these are open. In particular, SSH isn't open, right? That's the way we would like this device to be. We would like it to run. That's the way it's supposed to work. All right, I'm going to plug up another cable here for a second. It's not part of the attack. I'll explain it in a minute, but it takes a minute to boot. So let me get this other cable started, and then I'll tell you what it's about. So unplug a regular serial cable. Unplug my sensor, or plug in my special sensor here. It connects to USB here. Let's get that software running. Wait a minute. All right, and that is the software that runs that 8-channel analyzer. By the way, if you notice here, we'll see it waiting for just a second for that escape, and somebody typed an escape. All right, so now I'll tell you what I did. You can sort of watch this attack run as I'm talking, but well, it just so happens that not only am I good looking, but I'm also lucky. That resistor that I put in when I soldered this attack chip in place only allows a very small current to go through to protect the device. And that means whenever the administrator takes his regular Cisco cable and plugs it in, this 15 volts and higher current overwhelms the signal of my implant. So if anybody plugs this cable up, they will not see an attack, and the attack won't happen. This keeps the attack from happening. So this other cable, this is not part of an attack. This is just a high impedance serial connection, so we could see the attack and not block it. We can actually see what's happening. So again, this is just hardware that most people wouldn't have, but so that we can see what goes on during the attack. So now let's start the same thing down here where we will start pinging. So what this attack has done is it's used the Cisco password recovery feature to boot without a password. It loaded the existing config that was on there. I'll let the system administrator do that. I don't know what that should be. It turns on SSH, and it installs an account, username and password that only I know, right? So now I have SSH available with my own. Look, if you're going to hack a device, if we're going to attack this thing, we might as well use SSH and do it securely, right? So that is done when a cable isn't connected. That'll happen anytime a cable isn't connected. I've just connected this special one so we could see it. And ping is up, so it's gone through all those steps. it's rebooted. If you watched, you could see it do every command at a time. Oh, and here's the last command. By the way, the last step is ping. That's my address for this demo. So it sends out 4 ping packets. What's that? That's my notification that this device has been compromised, and now it's available. All right, so let's run Nmap on this device. And what do we get? We get SSH is now open. Thank you very much. Not only is it open, I've started up SSH. I want to do enable in this router, right? I'm connected to over the internet. I've hacked their router. This is across this Ethernet cable. The password. So the username is Sully. The password is Monster. Anybody know that reference? Sully, the Monsters Inc. Never mind. Okay, so show enable, there we go. We have full access to the device at this point, remotely across the network. All right, so I'm going to go back. I've got just a minute or so and talk about all right, so these are the steps of the attack. Again, just vaguely, but you can follow that from this Cisco password recovery document primarily, and a little bit of Cisco router knowledge. When it came up, we entered the escape character. That gave us local access. That's the password sort of reset feature. Now, so then we're allowed to boot it. We have root admin level access because somebody's in front of this device, or at least that's what it thinks with a serial cable. So they need to be able to recover it. We add the SSH, we add the account, add some routing, ping to let us know we're there. All right, so we said that the interesting implications here is that you cannot detect this hardware with any of your software scans, at least before the attack happens. It's not possible, right? It exists outside of your universe, outside of that space. It'll survive re-imaging. The attack is invisible because it doesn't happen whenever a regular Cisco cable is enabled. Like if I reboot it now, the attack will happen again. We just won't see it because I'm not there. So imagine this debug cycle. You get a new device, you bring it here, you plug it up, you set it up, you check it, you test it, it works fine. You unplug it, you put it in the rack, and when you power it back up, it gets the new config. Now, at some point, maybe you go back in and you scan all of your devices, right? Who scans their firewalls after they've already set them up and tested them once? Who tests them again when you move them in place? Very good. We have a few hands, much more paranoid people. So sooner or later, you might scan it and find out something's wrong. And you look at the config, and the config's got something added to it. So maybe you modify that, you change it. Maybe you pull this device and you bring it back to your desk. You say, what happened to it? And you plug into it and you set you set the config the way you want it, and it looks great. And you test it and it works great, right? And then you take it back to the rack and you plug it back up without a serial cable connected, and it gets reinfected. The config gets modified. So, all right, I'm just thinking that, I don't know, I think that kind of debug cycle would be funny to watch. So this is my kind of 1%, 1% of the effort model to show that it's possible. We could do some more advanced things. Right now, this attack only gets triggered when this device reboots. When somebody unplugs it and puts it in a rack, or the power goes off and comes back up, that's when the attack will happen. One of the things I could do instead is I could let it reboot and maybe run for a while and then do the attack. For that, I would need to find a reset line, probably find a reset line on the CPU and hit that. Might need a bodge wire. It gives me a little more flexibility, might be a little more visible. Just some thoughts for potential enhancements. I'm also sending these commands blind. I'm not looking for the responses. I could write something like an expect script. Expect is a kind of Unix utility to help you deal with serial terminals, to make it maybe more robust or fancier. I might be able to store password changes. So if the passwords, if I was actually reading all of the serial communications that came in the serial port, when somebody else was plugged in, if they set up a password, I could possibly read that password, store it in the EEPROM, and exfiltrate it somehow. Now I can get back in this device without having to add a new account. I could use the administrator's account. Not a feature I have right now, but something to consider for enhancements. Or if I'm going to put stuff in here, maybe I could build some kind of radio frequency communication or data exfiltration or password exfiltration. I do a little SDR communications work. Maybe you've seen my data diode hack attack. There's some video somewhere. So RF is interesting. So those are some of the ways that we could potentially enhance this. So defenses. How do we defend? How do you defend against this thing? I used to call hardware attacks Miyagi-style attacks. Who's seen the movie The Karate Kid? Okay, good. Because, he had, the crane attack. And what he said about the crane attack was, if do right, no can defense. Right? So I used to think that these attacks, there was really nothing you could do about them. But I don't really believe that anymore. I think there are some things that you can do reasonably. You could take a look at the hardware in your devices. If you're in a particularly sensitive site or industry, look, you probably don't do it by default, but you could pull it out and you could look over it. And this isn't, you're not going to see this right away, but I could teach an intern to do this in an hour or two, or somebody who's used to soldering and doing electronics work. They could say, hey, that looks hand soldered, which is different than the machine soldering of the rest of it. So you could potentially see that. That's not an impossible task. You could do regular configuration baselining, where you check the configuration of your devices against what it should be, right? If you do that monthly, weekly, daily, hourly, I don't know. But check this on a regular basis. My attack changes the config. So you could see that if you're monitoring the config on a regular basis. It's probably also a good idea to do firmware hashing and baselining. Can you pull the firmware off the device and make sure it hasn't changed? My attack doesn't modify the firmware, but if we're talking about defenses against some of these attacks, I would consider doing that for the firmware as well. Probably want to do some RF baselining in your plant, in your site. Is there a new transmitter that you haven't seen before? Again, sort of on the horizon of what we're doing. If you have a very mature security program, you probably want to start, your next step might be looking at RF. But that's for a rather mature program. There is one other defense against this one in particular. There's a Cisco command called no service password recovery that prevents you from being able to go through this password recovery. I have never seen a Cisco device that has that turned on. You be the first, or maybe you do it already. Anybody actually, it's probably not a bunch of Cisco admins, but anybody actually use this command? No, with Cisco? Yeah, no, okay, no hands. But you could theoretically do that, and that would make this attack more difficult. I wouldn't say it's 100%, I would say it was partial, because if I am capturing the user passwords on the way in and storing them, adding this line would not prevent me from attacking the box with the hardware device I'm using. But it's potentially, it's something that you could do and you should probably do. Like I bought several of these on eBay. none of them had that protection. They all had the user configs and password hashes and whatever. So I haven't seen anybody use it, but maybe you should. So what I learned is, look, it's not really that difficult. It's fairly hard to install if you sort of imagine, how do I get this into the supply chain? Maybe I resell these on eBay, or maybe I can do some social engineering like, hey, I have a bunch of routers for sale for your company cheap, or I can pretend to be a router reseller. I might be able to do it not by attacking, let's say, Cisco, for instance, but the supplier for Cisco. If I built it inside of these cans, maybe if I could convince Cisco to buy these from me, it would already be installed. Or if I had nation state level resources, I could interdict shipments and install the thing and send them back on the way. But right now, I think it's only for very kind of targeted attacks, not yet for everybody. Why not now? Why don't people go to this trouble now? And the reason is because between the time I started doing this attack and now, what Cisco has had, I don't know, 2 or 3 remote code execution vulnerabilities that they ship themselves in their firmware, right? So if they're shipping vulnerable stuff, look, again, no diss to Cisco. This happens to a lot of companies. But if that's already happening, I don't have to do supply chain attacks, right? So supply chain attacks are going to be for when you already have a certain level of maturity in your systems. Then your attacks will come from your trusted partners, and that's a good thing. When your attacks come from your trusted partners, that means your security is pretty good. And it's much more pain, it's much more difficult for me to go after your partner who might send a device to you. So it's probably not quite now, but I want you to look for it. It's next, right? After you get your security locked down, these attacks are probably next. And as my last comment, one of the things I suggested is to open up the motherboard and look for things that look peculiar or bizarre on there. And I found this factory original shmoo, that's a technical term, on the motherboard already. So in particular, there's this big glob of silicone. You can't really see it in here, but there's a big glob of silicone covering these. What's it doing there? I don't know, gluing things down, holding them together, insulating stuff. So I don't know. It looks a little bizarre, and there's a couple of them. And right beside where I installed this was before I did the installation, there's this like corrosion or stuff. You know, and after thinking about it a while, I'm wondering, well, could this already be a supply chain attack on this motherboard? If I'm looking at this and I see this stuff, could this already be one? And I'm like, no, of course not. Who would do something like that? All right, my name is Monta. Here's my contact info if you want to tweet something out and pick up one of these chips. Let me get off stage because we'll have other speakers coming up. But at some point you can come by and I will hand out some of these chips until I run out. Thank you for your attention. I appreciate it.
Thank you very much. It was really for dummies, this one. You managed to explain something really difficult so even I understood it. So, which means that you also answered most of the questions that came in.
Oh, well, perfect. Do we sit down or do
if you wish.
I'll follow you.
Sorry?
I'll follow you.
Yeah, well, let's sit down.
The way I don't get lost.
I'm getting old, so I need to sit down for a while. So awesome. Really interesting.
Thank you.
And as I said, most of the questions were already answered by yourself. But if we go back and talk a little about this in the perspective of what it means to the world, that's one of the questions here.
Well, again, I think in most security programs, there are other things to consider first. But once you start considering those, or if you're in a particularly sensitive industry or installation, it's time to start thinking about chipping attacks. They're easy enough that, if I'm thinking about it and I'm doing one of these attacks, other people have been doing this for 5 years, 10 years or more, right? Matter of fact, chipping sort of attacks go back maybe maybe into the 1940s. We could talk about some of those stories later, but get your other security in place first, but be aware of what's on the horizon for you. And what's on the horizon might be chipping attacks once your other security becomes more solid.
Right. So what you're saying is that you believe that there's already hardware out there that has been manipulated? Maybe?
I don't see, well, I see some evidence of old ones, right? There was the thing in the U.S. Embassy where a chip was put in a plaque. There was some chipping of old teletypes. I think that was maybe in the 40s or 50s. So yes, we've seen some of it back, what's that, 60 years or more, 70 almost, wow. 60. Anyway, so they have been out there. They do exist. The question is it practical for your attacker? Is it feasible? Is the cheapest thing for me to do to set up a chip fab and manufacture custom chips and harass a motherboard provider to get them in there? Right now, the easiest thing to do is probably look for vulnerabilities, things that you haven't patched, bad firewall rules.
Yeah. That was actually one of the questions. I mean, does it make sense to actually perform this kind of attack when there are so many software vulnerabilities out there?
Probably not yet, but it's starting to.
Great. All right, so one more question, and this is also very interesting. Who was the other person that spotted the chip?
I'm sorry, what?
When you said a person spotted the chip, when you show them your soldering stuff,
sorry.
You only mentioned one.
Well, one of them was a friend of mine, one of them I didn't know. So just a couple of people off the internet noticed it. So.
Off the internet, yeah. You didn't meet them in the street and just Starbucks?
No. I posted this on my Twitter account just to see if anybody could spot it without the red circle at that point, which you've probably seen thanks to Andy's article, by the way. By the way, Andy, thank you very much. I appreciate that. Okay. One more thing I forgot to mention is I do have a friend who used to build IoT devices. And he told me after I sort of ran this past him, he said when he sent his devices off to be manufactured, that they would often come back from Chinese suppliers with a different part or two on them, with some explanation like, well, the chip you specified doesn't fit in our automated pick and place machine, or these were cheaper, and now we've brought your motherboard back. So you would often get motherboards back that had changes on them with a good excuse, and they were a little cheaper, and as long as they passed his quality control, he was fine with that. So that might be the concept of having a change come through that gets okayed isn't such a wild idea after all.
Okay, thank you for that scary thought as an ending statement. Thank you very much, Monta.
Thank you, appreciate it.
Thank you, Monta.